Hi, this is my classroom observation 1. My driving question has to do with probing and justification. It is, how often does the teacher ask students to justify or explain their answers? Okay, so before we answer that question, we first need to understand what probing and justification is as a strategy. So probing and justification is a discourse strategy in which teachers ask follow-up questions that press students to clarify or expand their thinking and require them to explain the reasoning behind their answers. Basically, you're asking questions to deepen thinking and understanding. You want your students to have a better understanding of how they got an answer and what route they took to get that answer, and also how does this relate to other things. So it's just a lot of questions being asked in order to have a deeper understanding, deeper reasoning, and better knowledge on a topic. Probing and justification is not to be confused with rhetorical questioning or leading statements. These may appear to engage students, but they don't require students to explain their reasoning or defend their thinking. They're just questions and statements being said just to be said. So now I'm going to move on to a protocol for collecting data. This is sort of the way that I collected data for the YouTube video that I watched at the 8th grade classroom, the math classroom, but a little different. So first, you make a tally chart with 3 categories. You have the recall question, a reasoning and justification question, and then other questions or procedural questions. Second, each time the teacher asks a question, you mark it in the appropriate category. And then third, you record the wait time. I use seconds before a student answers. And then fourth is optional, but you note who was called on, whether the teacher called on one singular student, multiple students, the whole classroom, if she's only asking one student this different questions, or how is she or he going about asking these questions and to who. So this is my table. It's a little bit more complicated than the protocol I just gave, but that's because my brain has to be very organized and I have a lot of thoughts going on, so I had to break it up deeper. So I had the number of questions that my teacher asked, what questions she asked, maybe a little shortened, maybe the direct question, just depending on what my brain heard and needed to hear. And then right here you can see my categories. So I have my recall category, my reasoning, and I have my probing and clarification, justification. There's a bunch of different categories, but I put each question in a category. And then I have my wait time in seconds until a student answered. And then I put who she called on, and then I had notes just of what the question was doing to the student in that specific time in the class. So then I took my chart and I got these results. I made a pie chart out of my results, but as you can see, our recall questions, we had 5 out of 17, which is 29% of all questions asked. Our reasoning and justification questions, including our probing question, we had 12 out of 17, which was 71%. And then our procedural directions were mostly outside the coded questions. So we had 0. We had none of those within the questions. And then our wait time ranged between 3 and 7 seconds, so our average was 5 seconds before the students answered the question. So here's my little pie chart with this information on it. So from the results of my table, I can see that the teacher relied heavily on reasoning and justification questions, about 71%, compared to recall questions, which was about 29%. This suggests that the teacher consistently pressed students to explain their thinking, justify their answers, and clarify mathematical concepts rather than focusing only on factual recall. I also saw that the average wait time was about 5 seconds before students had the opportunity to answer the question, and extending this wait time could further potentially deepen responses, even though she got pretty good responses in those 5 seconds. These findings align with research on purposeful discourse in mathematics classrooms. From my research, I see that probing and justification are essential strategies for developing conceptual understanding, and I also see that the teacher's questioning strategy reflects best practices by promoting student reasoning, mathematical language, and collaborative sense-making. So, as a future teacher, these results show the importance of balancing recall for foundational knowledge with probing and justification for deeper understanding. Incorporating wait time and encouraging multiple solution strategies can further support all learners in engaging with mathematical ideas at a higher cognitive level. Here are my references. Thank you.